So we can see from figure 1.6 of the textbook that the textbook does quite a good job of summarizing how all of the aircraft equations of motions are interlinked, and the schematic of how the solution method follows through from set of equations to set of equations. You can see that this is an iterative process, so that you kind of solve for the you can solve for what the aircraft motion is doing at any particular moment in time, and take a snapshot of that, and then iterate around this loop to find how the aircraft behaves in general. So as long as we know something about the aerodynamic and thrust forces, so lift and drag, and then something to do with what the propulsion system is doing, and we also know something about the aerodynamic and thrust moments, we can make a start on solving the conservation of linear momentum equations and the conservation of angular momentum equations. Now remember, this set of 6 ordinary differential equations need to be solved together, and we solve these 6 equations to give us 6 unknowns, namely the linear velocity vector and the angular velocity vector. Now, the linear velocity vector can go straight into the flight path equations, but before we can find what the Euler angles are, we have to plug the angular velocity vector into the kinematic equations to find the changes in Euler angles, which we can then differentiate with respect to time, which are then integrated with respect to time, because these are differentials with respect to time, to plug those into the flight path equations. And then we can further take these to redefine our gravity equation to then complete this loop once again, once we've found the gravity vector, right? So in order to start this process, we need to know how the aircraft is oriented initially before we can start to iterate around and see how the aircraft moves. So once we have all of that information, the Euler angles and the linear velocity vector, we can plug those into the flight path equations to find the trajectory of how the aircraft is moving with respect to the Earth-based inertial reference system. So there we go, that's the aircraft equations of motion, that's the flowchart of how all of that stuff pieces together. So let's move on.